how they can help you achieve energy, water, and cost savings. My name is Corinne Buckley, and I'm a planner in the Environment and Development Department of the North Central Texas Council of Governments, and I will be moderating today's webinar. At this time, I'd like to go over a few housekeeping items. First of all, please remember to keep your microphone on mute until it's time to share a question or comment. Following all presentations, we are going to have an open Q&A session, but if you do have a question during presentations, please feel free to submit those in the chat during the presentations, but we are going to have that dedicated session at the end. Finally, the webinar slides and recording are going to be posted on the Conserve North Texas website under the event archive page after this webinar. So this webinar is sponsored by the State Energy Conservation Office, or SECO. SECO provides support for NCTCOG to tackle energy efficiency projects and needs throughout the region. And through this work, we coordinate workshops, webinars, and technical assistance on a variety of energy management, energy efficiency, water efficiency, and renewable energy topics. Here at the COG is a voluntary association of local governments. It's one of 24 regional councils in Texas, and the Regional Energy Management Program supports local governments in identifying energy management needs, provides greater awareness of local energy reporting requirements, and shares resources to support local and regional goals. So today's webinar is scheduled to last until 11:30. We will hear 4 presentations, and in the interest of time, I won't be reading our speakers' complete bios, but those full bios are going to be posted on the Conserve North Texas website with the webinar slides and recording for your reference. So I'd now like to introduce our first speaker, Cliff Braddock. Cliff Braddock is Director of Business Development for Metco Engineering. Metco Engineering is a leader in providing design-build services for on-site energy solutions that transform buildings and campuses into resilient and sustainable facilities. Mr. Braddock originated many bellwether projects, such as Austin Energy's Mueller Energy Microgrid, that earned Dell Children's Hospital as the first LEED Platinum healthcare in the world. He is now developing neighborhood resiliency centers for counties and municipalities. During his long professional career, Mr. Braddock has served on multiple boards and committees affiliated with sustainability, engineering, design, and energy efficiency, as well as written many industry papers and co-authored a guidebook on district energy for the International District Energy Association. And now, Cliff, you can go ahead and take control and begin your presentation. I believe your microphone is off, Cliff.
That is fantastic. I was just saying I'm going to do a quick AV check. Did you hear me and see me? And did the slide advance? And are we good now?
Yes, I believe you're at the beginning of the presentation, so you'll just need to move forward to your slides. Yep, perfect.
Oh, there I am. Boy, that's a good looking guy that's on there. All right. So yeah, we're going to jump right into this. All right. So I assume that the slide is filling your screen, and you can see that finger pointing, and who is it pointing to? And hopefully it's pointing straight out there at you, unless if you get your screen set right. And so this presentation is going to be about you, and you are people who are involved in managing the life cycle of, we're going to assume that it's public buildings, but it could be private buildings also. So I'm going to set the discussion today, and it's really about you and your relationship with your buildings and your facilities. And you are in control. You have the most impact. And so we're going to, hang on to your seat here, and let's get going here to understand why you are so important. So as we get going here, why do we have buildings in the first place? Facilities that we work in. I mean, what do we want from them? And I'm going to say that you want them to be energy efficient. You want now you want to go on the path to net zero. You want a productive and comfortable work environment. You want good, high quality indoor air quality. And then, are you the one that designed all of that? Are you the guy that, or the lady that made it all happen? And I'm going to say probably not on the original design. You had codes and LEED and other things that drove it. So you didn't have a lot of choice on what was given to you, but do you have choice on what happens in the next 30 years life of that building? And that's the O&M side of things, operations and maintenance. And that's where this webinar and that's where our presentation begins. It's the O&M side of things. So looking again at what we expect from our buildings, look at how much of that are you actually in control of. The design attributes of a fantastic public building. You want it to be, productive and efficient for your staff and your visitors. And did you design that? Probably not. Other people were involved, but did they have the freedom to get it right? Well, sort of. There's codes out there. They couldn't get a building permit unless it complied with the majority of the requirements that we have. All right, so the design is out of your hands, but what about all these other factors that are in there? Energy efficiency. Was that original design required to be energy efficient? Well, it had to meet code, but what about going beyond that? And how about maintaining that energy efficiency over a period of time? What about resiliency? We're not going to, I wish we were in person, we could raise hands. How many of you all are faced with making your buildings more resilient? We see a transformation in the market or in our industry of public facilities and private to look at resiliency. And myself, having come from the utility industry, I'm sorry to say that I think that the need for resilient buildings is increasing because I don't see that the grid's getting more reliable. There's just too many factors that are out there. So resiliency is a big deal. So was that required when your building was constructed? Probably not. Is it something you need to do today? Perhaps. And so there's a way to do it with on-site energy and microgrids and such as that. Decarbonation. Carbonization, when your building was constructed, except for compliance with LEED and maybe a couple of other criteria, what's the carbon footprint look like? So the point of this little slide is that there's a lot of features of your building that you want that the only guy who's going to make it all happen. And by the way, I'm just going to use guy generically. That's men and women and whoever that's operating responsible for the O&M of your building. And that's you. You're responsible for those. Where it has no in there, that's you. All right. So let's going to take a look at life cycle. Just to be clear, does everybody know what life cycle is? And I can still remember a long time ago, somebody mentioned, do you know how to do life cycle cost studies? And I said, I don't even know what your question was, much less do I know how to answer it. So that is defined as the cost to the owner of a program over its full life, including the cost for the initial design, construction, subsequent annual costs for operations and maintenance and repairs and refurbishment of the building, and then the eventual demolition and recycling of the materials, life cycle cost. So when you look at the life cycle cost of your facility, which area do you think is the most expensive? What areas do you have the most control over? Well, before we answer that about your building, let's look at some other industry of the life cycle cost. And this may be helpful whenever you all go out and talk about life cycle cost on your building to other folks. What does it cost to own and operate an automobile over its life expectancy? And if you look at statistics, average cost of a car, 33,000. We put about 15,000 miles a year. We keep it 12 years. So where is the majority of the cost to own and operate that automobile? So you have a lot of costs that are involved, the depreciation, the fuel for it, and then the ongoing maintenance. Sounds a little bit like a building to me. So when it's all said and done, that initial cost is just a quarter of the overall life cycle cost of this automobile. You will spend $121,000 equivalent cost over the life of that 12-year life of this typical automobile, which works out to 65 cents per mile. Did you all know that? I mean, your car is 65 cents per mile. Kind of that's what the IRS will allow for your depreciation, for your write-off on using your automobile. And the message here is that the initial cost was just a fraction of the overall life cycle cost. So what's that got to do with the building? Guess what? The numbers are not way different. On a building, there's some variability about this, but generally speaking, a quarter of the cost of the life of that building is embedded in the initial cost. That's the design guys and the construction, and 75% of that, the cost of that, the life cycle cost of that building occurs over the 25 to 30-year life of that building. So it's not the builder or designer and the contractor that controls the majority of the cost. It is you, the facilities operational staff. And that's what we need to hone in on with this webinar, is addressing that long-term cost. So I think y'all are getting the message, but one more slide about those ratios. And I found this kind of interesting. I didn't realize you could go on Wikipedia and look at the 1-5-200 rule. If you don't do it right now, you need to stay focused on this webinar. But if the initial cost of a building is a 1, then the O&M cost is a 5. And just to be clear, the largest cost of operating a building is not really what we're discussing in this webinar. It's the salaries of the staff that work there. That is by far the number one cost. And you may or may not have control over that. But it's that O&M cost that you do have control. Yes, you, me. So like the photograph there. All right, so where do you begin if you're going to take a look at these ongoing costs? And I think it may help a little bit with some famous quotes. And some of y'all have probably heard this before, but it never hurts to remind ourselves that you cannot manage what you do not measure. So I have a controls background, and I know some of y'all on this that are tuned in here today also have that. And if you can't control something if you're not measuring it. You know that. So you're kind of shooting in the dark, and you don't really hit the target when you shoot in the dark. So you need to do some measurement. So what do you want to measure? How about KPIs, key performance indicators? What is important to measure? And the energy utilization index, the first one there, the BTU per square foot, that would be something that's a kind of an eye opener. That's a little bit like a scorecard on a test. And then the energy cost index, the dollars per square foot. If you're going to measure the resiliency, there's a tier rating by the Uptime Institute that you can use. And there's also metrics that are reported to the PUC by your utility about the average duration of outages there at your facility. And we're going to do a deep dive on the decarbonization a little bit later. And we'll have more information about how you're going to measure your scope 1, 2, 3 emissions. So where you begin is looking at some of these key performance indicators. So let me just give you a little quick story here for a moment. If you're in the medical business, like a doctor, and you go into the doc's office and you tell them, I got an ailment, what's that doc going to do before he even talks about your complaint? In my opinion, he takes KPIs. They do KPIs on you, key performance indicators. They're going to measure your blood pressure, your heart rate, your oxygen content. Do some of these vitals before they do any assessment of whatever it is you're in there for. So most industries, before you analyze, do a deep dive on your problem, you need to look at the key performance indicators and measure like where you are. So I think that's very important to do. But that being said, let's see if this little thing works. Yes, it does. Everything is not necessarily need to be measured. That's your second quote there from Mr. Einstein. So he says that everything that can be counted does not necessarily count, but everything that counts cannot necessarily be counted. Maybe that's a tongue twister. So I think the point of it is, just because you can come up with a KPI, it may not be necessarily relevant to, the end game. So those folks who know me know that I love a Pareto principle, and it applies to you in whatever you're doing and wherever you're going and so forth. And just as a reminder, that's the 80-20 rule. That's what the Pareto principle is. So 80% of the benefit that you're going to get out of the modifying your facility is just going to come from 20% of the activities that you deploy. So let's just phrase that again. You focus on the high priority items and you'll knock out 80% success. And the remaining 20%, maybe just leave that up to noise. So does that make sense to you? The 80-20 rule applies to everything in life. So just keep it in mind. So here's an example of why you don't necessarily use all KPIs. So do you think a KPI would have pointed out this? I'm not sure if y'all can see on the screen here. These are real live photos made not too long ago. And I see Garrett's on this meeting notice. He knows what I'm talking about. These are on projects that we are actually working on. And I'm shocked. I don't even know what my emotions are when I see, what we found. But the one on the right there is a multi-zone air handler unit. And the actuators have been disconnected. But thank goodness the owner has some very strong inventory of magic markers. And they have written, heat is this way, cool is that way. And so when the people are hot or cold, they just simply go up and put their hand on the damper rod and just slide it left and right, and they can get comfort if they wait long enough. And like the solar system over there, absolutely no maintenance there for the greenery that's growing around the PV. So we've got some degradation of output over time due to zero maintenance of those systems. So my point is, I just told you that KPIs are real important, and KPIs you can get from taking data and manipulate it, not manipulate it, but calculate it, and then you'll have your KPIs. But some of the things that are important to us are not necessarily calculated like that. What we would say is go see your maintenance staff and let them tell you, what some of the issues are. So in the case of that air handler unit, the maintenance staff has been very loud with their management team about the deficiencies of this air handler unit. And it's kind of fell on deaf ears. And so until we get some of these common sense problems taken care of, it's a little hard, to have that, to use your KPIs. So it's not always about counting the KPIs. Sometimes it's just common sense to go look around and let your eyes do some talking. All right, well, let's talk about a cycle now. You're going to see in this webinar about, we're going to go all the way to decarbonization, and I'm introducing to you resiliency and energy efficiency. Have you really connected, realized that all of these are integrated? One feeds into the other. So we have enough time here today. I think I'm not asking us to have a debate or an argument over this, but I'm going to suggest that the number one area to focus for any building is energy efficiencies. So if you're looking at anything, resiliency, decarbonization, indoor air quality, or whatever your driver is, energy efficiency is paramount. And fortunately, that's a very mature industry. So you know what you need to do. You need to reduce your kilowatt hour usage, reduce your kW demand, try to address hot and cold spots inside the work space. And your goal is to reduce your cost for utilities. And if you have no idea where your building stands, we need to get a KPI. So where is a good place to get a KPI for the energy efficiency of your building? And the good news is your tax dollars have paid the EPA to create the Portfolio Manager program. It's you just need your own account, which is a password and an ID, and you're free to use a very valuable software tool for measuring the KPIs of your facility. So you can get your EUI, your energy utilization index, your energy cost index, some emission indicators, and some other great information from using Portfolio Manager as a tool to measure your energy efficiency. So energy efficiency is a great thing because it can reduce your kW and your kilowatt hours. And what does that do for you outside of saving money? Well, if you're headed toward resiliency, how do you get a resilient building? We're working on resilience projects right now that consist of on-site production. You can use gas or propane and solar energy to produce power on site. There's energy storage with batteries, and with all that properly connected, we can isolate from the grid and continue on with service without the grid. Now, that solar and that generator and so forth, that stuff is expensive. And you could say it has a big dollar amount on a per kW basis, cost per kW for a solar system. So how do you make that cost as low as possible? You want to have the system as small as you can get away with. And how do you get it small? Well, you need to do the number one thing first, which is the efficiency. Reduce the kW demand and the energy consumption of your building, and now your cost to do the resiliency measures is going to be less than it would have had been otherwise. Now then, let me just introduce to you, some of y'all may not know about this. So how are you going to measure your resiliency? That is, and I'm going to tell you that it's hard to do that. It has to do with, how much outage do you have every year? What is the disruptions that you have every year? And so how do you get a KPI on that? And I'm willing to share with this audience the outcome of what I'm getting ready to tell you. I'm working on answering that question for a couple of projects right now. And so I am going to the Public Utility Commission to ask them to release those codes, those names that are down there. That's a system average interruption frequency index, that's system average interruption duration index, and then the customer average interruption frequency index. Those are, I guess, fancy words for just saying how often do we have outages, how long do they last, and then how long does a customer have to wait before it's restored. So that data is mandated to be reported to the Public Utility Commission in Texas by every utility. Now, some of our really resilient utilities, like El Paso, they are proud, and they publish that information on their website because they're number one in the state. So they don't hold it back. But the rest of them, and we won't mention any of them down in the Houston area that may have numbers that are not so proud of, and therefore they're not posted. But nonetheless, I'm going to try to pull that out of the PUC. I may have to use a FOIA, Freedom of Information Act release to get the data, but that data is there. And I worked with a utility, and that data is measured and monitored and reported literally for every feeder that the utility has. So the information is there. It's just that we common folk don't usually get to see it. So if you have resiliency in mind and you're serious about a resiliency project, we could talk a little offline about collecting that data for your feeder at your particular building. Anyway, resiliency is real important. We need to keep some of our facilities up all the time. All right, decarbonization. We're going to, we have more on that momentarily. A good quick way to get started on decarbonization is, switch to renewable energy sources. And as we already said, an efficient facility is a smaller solar system, more affordable, and it'll also have the reduction in, your scope 1 and scope 2 emissions. So just as a little side note there, look at those check marks in there. This is the carbon offsets, for a solar system. And in case you didn't know it, I believe these are true. They came off the internet. It has to be true. So CO2 reduction is greater for solar on a per acre basis than a forest, which I didn't realize that till not long ago. And sometimes people say, well, the emissions just to build the darn solar system are so great that it takes forever to get it to even break even. Well, 1.6 years is not really too long. So solar PV is a great thing to go after. It's free fuel, and so knock on wood, it's not regulated as far as the fuel. There's no surcharges and taxes on God's energy that for our fuel. All right. So let's just pause for a moment. The number one, efficiency. Number two, resiliency. Number three, decarbonization. Do you see by now that these are all integrated? So when we take on a program to address all of those, or any one of them, they have effect on the others. And remember where we began on this little chat here. You are now addressing 75% of the life cycle cost of your building whenever you take on any one of these three activities, the efficiency, resiliency, and decarbonization. So I'm suggesting that there be an action plan for your buildings. Uh, your architects and engineers gave you the building. Now then, what are you going to do with it? It's to operate and maintain, the efficiency, resiliency, and decarbonization. Begin with benchmarking. If you haven't benchmarked, get with it. Our organization, I don't know if it was good or bad, but we raised our hand not long ago saying, hey, we'll do portfolio manager. And we ended up, a bunch of public agents, public and private said, hey, just do this benchmarking for us. And so we can see what's going on between you and me. I don't know why they don't just log in and go do it themselves. But anyway, as a consultant, I guess it feels better to have somebody on the outside go do it for you. But anybody can log into Portfolio Manager and use that tool for your benchmarking. And don't forget about the Pareto rule, the 80-20 rule. The good thing about energy efficiency is it'll pay its way. I had my day has already gotten a little bit not old, but we've already had a meeting earlier today with CECO over something, and we were talking about the ROI on solar and solar with batteries. So there was a day that solar didn't pay for itself. I mean, it wouldn't do it in the 15 years, but those days are in the rearview mirror. So PV is a good thing to do. So the idea here is smart integration with you as the captain. You can deliver these energy efficiency, resiliency, and decarbonization. So I'm trying to set the pace here for our webinar, and I think that's kind of my messaging, and we can do a deep dive on anything and everything, these concepts that we're throwing out there. So we want to continue that discussion. So Corrine, I'm done here for right now.
Great. Thank you, Cliff, for that presentation. Very informative. I'd now like to introduce our next speaker. Can everyone see that speaker introduction slide? Yes? Perfect.
Yes.
Okay. So I'd now like to introduce our next speaker, David Handwork. Oh, and there goes the slides. Hold on. Okay. Give me just a moment. Okay. Perfect. So David Handwork is a founder and principal consultant of NTech Consulting LLC, formed in 2016. David brings over 30 years of facilities operation, energy efficiency, and capital construction knowledge to his clients with a holistic and personal approach. David also serves as a fractional executive engineering officer for United Commercial Energy Partners, supporting facilities decarbonization solutions in Texas and border states. David's 30 years of professional experience includes major capital construction management in higher education and food processing, engineering design, and management of multiple teams of professionals. His professional leadership in ASHRAE, APPA, CAPPA, and other organizations is a testament of commitment to advancing and promoting the field of facilities management. And now, David, I will hand it over to you to take control and begin your presentation. Oh, you're on mute, David.
I did the same thing. So that's we try to be quiet, not disruptive, but we forget that when we need to jump in, we need to jump in. So happy to be here. Glad to go through this important topic, something I'm very passionate about. One thing that you should know that I was a facilities manager for 20 years of my career at a university. So I bring more a practical approach and more of a on the ground approach as well, but work in the consultant world as well. And so I'm going to go through, and you're going to find that the theme that was put up forward with Cliff is going to integrate all throughout this presentation and seminar. And we're really focused on how do we get to where we need to be, which is net carbon zero, and what are the driving forces. So really want to go through, just kind of talk about where the energy codes for new construction and renovations is at today, especially for Texas, and what the timeline is for these codes. One thing that you'll see on my bio, I serve on ASHRAE 90.1, the standard for energy code for mainly commercial buildings and public buildings in the public space. But also I'll talk about IECC, but there's a timeline for both of those for new construction and major renovations, and really kind of give some pragmatic type of how you can get from where you are today to net carbon zero of going forward. So jump in. So the two codes that you're probably familiar with is ASHRAE 90.1 or the International Code Council, the IECC, the Energy Conservation Code. When you look at those vary by state and county and jurisdiction, and by the public agencies. Some public agencies may recognize 90.1 only and not IECC. But most jurisdictions recognize IECC by state, and that's really where, when you get into public code officials and city municipalities, you're going to see IEC as probably the dominant, but 90.1 works with IECC, so they're pretty close. There is nuance between those. So when you look at the state of Texas, when you look at the IECC, we're currently under the 2015 version of that. The most current published version is the 2024 that it just will be recently published. It has to go through some governance on that to really happen. They're on a 3-year code review cycle now, and it's different. It's a standard within the ICC. It's not voted by like the other codes in ICC now. That changed in around 2019-20. When you look at 90.1, the current version is 2013, where you saw on the previous slide that Texas kind of leads the bordering states with the most current version. The Texas is parallel with New Mexico, but certainly leads the most current version, and the current published version of 90.1 is the 2021 version, and 2025 will be published shortly. So when you look at Texas, you got the most current versions there. I know all states are reviewing the most current version of 2022 and 2021, because mainly the grants and that's coming out with the Inflation Reduction Act, the other stimulus bills that came out, they add enforcement of the most current versions, and are also adding incentives to go for states, municipalities, and other jurisdictions having authority to bring up the most current version. There will be more dollars coming out to really kind of perpetuate the most current version, so there's not a lag and delay. You saw on those previous slides, some states are more than a decade behind with the most current version, so that's kind of lagging the energy efficiency driven by codes and standards. And so, but you see federal agencies really jumping up and taking the most current version, but there's still some giant leaps. And this slide may be a little bit difficult to read. This was published in 2020, but it was showing a progress report, particularly of 90.1, of how to get net carbon zero emissions. And you'll see that there's some dotted lines of advanced measures, rooftop solar offset. They were saying that in order to get there, the line is moving too slow with the version of 2019, and that you're going to have to bring in more advanced measures. And that was true with IECC as well. So you're here with Texas, when you're relative to the 2004 version of 90.1, you're only about 70% to net carbon zero based off of a code. IECC was a lot flatter curve, so they have more challenges to get net zero energy efficiency, and you can see the 2018 version there for Texas. So filling the gap is what you have to do. There's these percentages to get to net zero emissions, and so it's a long ways to go. So how do you get there? Well, the codes have said, let's get a performance path where we can get a code of proposals. Oh, excuse me, I need to back up, say here, where IECC saw the gap. they changed their publication cycle to a model energy code. So there was a series of challenges to proposal during the adoption process. So they said, let's change how we do our process. And so there was multiple stakeholders in the ICC plan to get in the carbon zero that said, let's get this moved to a different type of review for IECC, and so that we can go do what they call a glide path to net zero emissions. So they're both IECC and 90.1 have a plan for the next 3 code cycles, which falls in the early 2030s for both codes to be a net zero emission standards and codes. Now you'll see the adoption cycle lags, so it may not impact the municipalities and states in their code adoption cycle until the late 2030s, unless you're a public agency and federal funding requires you to be the most current version, then you're going to have to adopt this. So what does that basically mean? Both standards are going to have advanced measures for all your plug load controls, which is, right now 90.1 ICC has occupancy sensors tied to some of that. You're going to see more elevated management of that and some unregulated scope. And you're going to have advanced envelopes that's going to be prescribed. And there's going to be, there's already in 90.1 a HVAC system performance that is calculated. So that's going to be increasing so that your holistic system has certain levels of performance that's going to be prescribed. So they're all going to require some level of electrification of your facility systems, getting away from carbon-based type fuels that are used like natural gas or propane. So you're going to see more heating requirements with electricity or heat pumps. So if you got a chiller system, heat pump chillers have been around for a while, so that may be an option. How do you do with process heating? That will be not regulated on the short term, but you can see that probably coming. The whole purpose is to get net zero emissions, so you're trying to get as much as the carbon-based type of energy eliminated from your facilities relative to codes as possible will be happening. They're already requiring some renewable, certain level of prescribed renewables. And that is maybe in the current version. So that may not apply to all facilities, but you're going to see eventually to get to net zero emissions, you're going to see the prescription of renewables, either site or offsite, be required as part of new construction and major renovation. And then most of these standards are supported by federal legislation. Here's some examples. So you had the Inflation Reduction Acts, which had funding for really having zero energy codes. And I won't go through all the details. I'm just showing this as an example. This was part of the IRA. So this is what they're trying to get to, at least in 90.1. As you go in the code cycle of the 2031 version, you're going to get to where your 0.35 of the 2004 version of energy efficiency, and then these renewable offsets at the bottom of the graph, those will be what steps up as you go forward in the code cycle to get to net zero emission. And I think I have a slide where, here's where we're at with ASHRAE in Texas. So you can see even coming up to the most current code cycle in 2031, there's a lot of steps that have to happen. When you look at, this is the most current version, so even getting to that is a lot of steps. Now you have 0.3 in renewable energy offsets, and that's going to step up to 0.35. So you can imagine what that's going to do for, costs. But here's the kind of the trick question. Will Texas and will municipalities within Texas adopt this code? There's already pushback right now because of certain factors. Some of it's political. Some of it is driven more for the cost of this construction is going to go up. And that can be called political, but it's also definitely when you're dealing with certain construction types, especially multifamily housing, increasing costs. You're seeing like some states with North Carolina, they said they're going to put a moratorium on freezing the IECC, because of the multifamily housing costs that they did their analysis of the cost increase. There's also Colorado saying that they're going to mandate, on the other side, they're going to mandate energy performance besides the criticism. In the state of Texas, Governor Abbott in the last year, he vetoed part of the energy efficiency bill. And so there's a lot of reasons for that, but the point is that there's not a full adoption in all states of these bills, and these are some more examples. I'm just rolling through real quick. Very interesting. The St. Louis had a residential energy code update, but the state of Missouri overrode that and said, no, you're not going to do that. I'm the type of person, if a local municipality said they need to do that and their citizens voted that in, let them do it. Don't let the state step in. But that's outside this purview of this, but that's an opinion. So we got to have the impact. We're going to have electrification of buildings. So if you got existing buildings that you're doing a major renovation and these codes apply, you may not have the infrastructure that you need to feed to that to electrify the heating and air conditioning of that. The building systems are going to be more complex as you put more types of controls and strategies on it. So that's going to require a different level of maintenance and operations. And we talked about in the previous presentation, the total cost of ownership or the life cycle cost, that's going to increase. So you're going to have to figure out how to operating costs to go up. And then the jurisdictions are going to have more staffing for requirements if it's required for part of your funding, federal funding, or even if that jurisdiction says that we're committed to this, you're just going to have more staff. And then we're going to figure out how to deal with on-site, off-site renewable. Texas land is available. Other states is not going to have that luxury. So how do you deal with that? Other impacts on the design is, first construction costs. I was director of planning, design, construction, so I have some basis of this, but I'm just doing a guesstimate that we're probably going to see a 10 to 20% increase of first construction costs with the adoption of the most aggressive forms in 2031. Total cost of ownership may or may not increase, though, when you look at energy savings and other factors, but it remains to be seen. Operating costs should decrease, but again, I've already talked about the technicians. But then the compliance could result in penalties and fines. Public universities may have federal dollars tied to research, or even Pell Grants may be restricted or reduced or eliminated if you're not meeting some of these codes sometime in the future. So what do we need to do? We're already decarbonizing new buildings via code. So we've got existing buildings. So how do we deal with that? As you go forward, you may not be doing a major renovation where codes and standards are applied, but there's a pathway to actually get to these decarbonization, whether it is prescriptive via code mandates or you can do it voluntarily. So, existing buildings, the actions that we're doing in existing buildings, I'm going to say it's virtually non-existent because it's all driven by economics, or even with an entity that is committed to decarbonizing their facilities. It's very difficult because it's a slow process. Because you look at the CBEX database, most buildings are constructed prior to 2010, and it's very limited on the type of DDC controls or other features in there. It makes it very difficult to decarbonize. So, and of course, we've all probably heard this a statistic that buildings in the United States, even in the world, but they consume about 40% of energy. And I got pulled that data from the CBEX database. But there's also common barriers of, just general capital funding, how do we replace fossil fuel systems? And then we just don't really have the technology leap yet to really get to where we need to go. So how do we get there? So we got these large energy plants. If you got large facilities, large campuses, so you've done this investment, and I'm really talking from my facilities manager role that I had at a university. How do we do this? And so that's a challenge. And then how do we get renewables if we have some of these other stumbling blocks or restraints? And then how do we get with the other competing demands for energy? We have a growing population, we have e-vehicles, we have AI that's competing for energy. We have other factors that are coming into play that's putting stress on our grids. And then we have, the government misaligned, what I'm gonna call government funding. So the politicians like to go for pretty quick wins, and they are not rewarded for doing long-term vision scope for, because if they do, they're probably voted out and don't see it come to fruition. So some of that needs to change, and then we just have to have more long-term goals instead of short-term wins. So how do we do this for existing facilities? I mean, it's pretty easy. You just need to go and just really do aggressive energy optimization right now. So that is a very, very, usually a very quick ROI. You can probably, some activities are not even tied to behavioral of the occupants, but you can, with technologies that is available that today, you can implement on existing buildings and do some retrofits and probably have an ROI of 24 months or less in some cases. So you need to kind of look at your occupancy and just, I mean, a lot of times the best energy conservation is turned off. And what I mean by that is that if there's nobody in the building and there's no reason not to run your systems for data centers or other types of requirements, turn the systems off. And then you match and coordinate these systems operations with optimized occupancy of the buildings. DOE, the New Buildings Institute had studies where there's potentially 30 to 40% savings in these type of step one type of scenarios. So it's quick payback, usually investment $2 to $4 a square foot. Step two, once you get past that, when we came out of COVID, and this is more related to commercial real estate and even, where you have in higher education where students are doing more remote learning, those type of factors. So our spatialization is much, much lower. I've seen some numbers in other parts of the country where commercial real estate is down as much as 50% utilization. In Texas, it probably varies by, North Texas, utilization is pretty high because there's high demand. But you got to have, and if you're going to, even with high demand with utilization, you have to have a top-down type of approach where you're going to be committed because everybody wants to own their space, and we tend to use more space than what we really need. So you got to really kind of deactivate these unused spaces and really put safety backstops in there so you don't have unconditioned space that creates other challenges and other liabilities. And then you expand those energy optimization with optimized spatialization. This is a very hard nut to crack because of the ownership of space and giving that up and having full control of unoccupied spaces. But payback is usually pretty quick, but cost is pretty low because 25 cents to 50 cents a square foot. And if you do it with step one, it makes the ROIs come down a lot faster. So when you look into the next step after that, and you got to really kind of look at a multi-year decarbonization investment. These aggressive goals where I've heard entities say we're going to be fully decarbonized by 2030. And it comes out of a directive at the highest levels in a press release, and then they haven't pulled in all the operations people to figure out how to implement that and what's the cost. I've seen smarter plans from different entities that studied it, and you're seeing more realistic if you're especially like in a retail type of setting. And the largest retailer in the world has a plan to be totally carbon neutral somewhere in the 2040s. And that includes scope 3. So you need to put together a multi-plan that really makes sense and look at the discipline that requires for this multiple year that goes out there in electrification of your facilities. And this may take 10 years to do and implement, but you have to be disciplined and you have to follow these plans. Once you get through, say, 5 to 15 years of step 1, 2, and 3, then you can start looking into, as we go in the future, and technologies that's coming forward. And so you really want to reduce with those step 1, 2, and 3 to get your EUI, your energy use index, down to, on just a basic commercial facility, less than 30,000 BTUs per square foot a year. then you can start putting these other factors in, and it makes sense to right size your renewables. I agree that solar, with the prior speaker, that solar now has a cost justification. If you own your land, if you have to go get more land, it may get more difficult. But you can get into newer technologies that's available today and they advance in the future. They're going to include a lot of these different types of on the edge and also market available. And so we're, um, as we get into energy storage, it's going to make renewables more viable. The thing that I'm watching right now is long duration storage, and I think that's going to advance in the next 5 years, and we're going to see a lot of that. But we're going to see a lot of these other kind of really interesting technologies. Continuous air purification that is already in some markets, and why ventilate a building if you can purify the air and make the IAQ better than bringing in outside air. I'm not saying eliminate outside air. I'm just saying minimize it so that you can get good IAQ. And just all these different artificial intelligence will be a game changer, but it's not yet. It can do generative AI, but when it can start doing mathematical functions, then we can start applying that to energy optimization and planning. Things that are like super insulation, OLED film lighting, where you just have your whole ceiling is a light. And so OLEDs are been around, they're on our phones. And so, but there's a lot of testing in the emerging market. They're very low power, high efficacy. And so the things like that are going to change when we can get to net zero emissions pretty quickly. Will we get it in as an economy by 2035, 2040? I don't think we will. Do we need to be totally carbon neutral? That depends answer. But we need to work and strive to be a net zero emission, but also a net energy independent economy so that we can lead the world with decarbonization, but also lead the world with energy independence. So there's less dependence in the global market relative to the issues of efficiency and decarbonization. So with that, I'm going to turn it back to you, Corinne.
Great. Thank you, David, for that presentation. I did just want to remind everyone that we are going to have a Q&A session at the end, but you are welcome to put questions into the chat throughout the presentations. So I'd now like to introduce our next speaker, Liz John. Since 2015, Liz has been with the South Central Partnership for Energy Efficiency as a resource. As the managing director, Liz builds relationships with funders, partners, and members and manages day-to-day internal operations, including organization, communications, deliverables, and reporting. In this role, she works closely with SPEER staff and the organization's efficiency initiatives to ensure that all SPEER programs meet required deliverables and achieve success and sustainability. In addition to overseeing SPEER's energy codes, policy, and local government programs, Liz also manages the National Building Operator Certification Program, in which she leads the implementation of the training course to current and potential building owners, operators, and facilities managers. So Liz, if you want to go ahead and take control of the screen, and you can begin your presentation.
Sure, thank you. And thanks to NCTCOG for having all of us. Really excited to build on some of the information that the previous speakers just touched on, a lot of really great information. So we'll be talking about the Building Operator Certification Program, and I'm going to dive a little bit more into that after I just briefly run through what SPEER is. SPEER is a nonprofit energy efficiency organization. Our territory is Texas and Oklahoma. We're one of 6 RIOs in the country. And here are our main program areas. A lot of our work focuses on educating legislative staff and promoting policies that advance energy efficiency technology and research. We do a lot of in-field training with building energy codes, helping, and Cliff touched on this, helping cities adopt and implement stronger energy codes. And our mission is to accelerate the adoption of energy efficiency products and services throughout our region. And this is just kind of a map of the RIOs and the states that are in each of them. This is what I will cover on the Building Operator Certification Program. We'll talk about what the training is, what you will learn in the course, the credentials to maintain it, and then a few potential funding opportunities for it. So BOC is a national training program, and it was created to optimize building performance. It's been around since 1999. It was created by the Northwest Energy Efficiency Council. As David just touched on, discussing getting to net zero, reducing energy waste and carbon emissions, are necessary with stronger building codes. And the building sector emissions with electricity use accounts for roughly 34% of greenhouse gas emissions nationally. So what the BOC program is doing is helping facility managers and operators learn how to utilize technologies more efficiently, and with new AI, sensors, building performance management devices coming into the market, we need these folks to be trained on how to properly use these devices to reduce energy use and waste. Of course, these graduates will extend the lifespan of HVAC systems and units, make buildings more comfortable, and on average, graduates save roughly $10,000 a year for 5 years, which makes the cost and savings, you pay for it almost immediately in the first year. And this is who typically attends BOC training nationally. Higher education and government make up the majority of the training. SPEER has worked a lot with universities, cities, and utilities for the trainings over the past 6 or 7 years. So how do you know if your building is running efficiently? Many have room for improvement, and energy problems can lead to comfort problems. Many buildings can reduce energy use by 5 to 30% while improving comfort in these buildings. So let's talk about the energy savings for BOC. BOC is one of the only training programs with third-party evaluators. Sometimes facility departments are seen as a resource center for using energy and staff. So anything we can do to save money and energy going into that department is largely helpful. Up to 12 to 13 states accept energy savings from the BOC. And all of the savings reports are on the National BOC website. They also include water and gas as well. And this table that you were looking at summarizes 20 of the most recent and relevant BOC impact evaluation studies. And of course, it's important to note that these studies use different methodologies and assumptions, and you have to have adjustments for the general results. But overall, there are 17 independent third-party evaluators show that on average, as I mentioned previously, the typical graduate will save their building $10,000 a year in utility bills. Let's touch on the benefits beyond just energy and money savings. Of course, these facility managers increase job safety with the knowledge that they gain. They will improve the productivity, equipment lifespan, building performance. Of course, you improve your indoor air quality, occupant health, and it reduces turnover. You have well-trained technician staff and operators that can make decisions quickly, and they feel more empowered to do so. So this is a career map with 3 different levels of the training. Fundamentals is for folks who are maybe interested in getting in building management and don't have a base level knowledge. It covers, building system basics, the fundamentals of indoor air quality, and you don't have to have any prerequisites to enter into that. Level 1, we do encourage students who are going through this to have either 2 years of experience under their belt or have taken some education prior to this. It's a little bit more in depth than fundamentals. They touch on HVAC controls, a full building scope. You learn, you kind of take, and I'll touch on this later, but you the students take what they learn in class and apply it to hands-on project in their facilities, really just to engage them and make sure that they are able to put into action what they are learning into the classroom. Level 1 will also cover operations for improvements and dive deeper into energy efficiency. And then level 2, they have a full project that they will present to all of the students in the course, and it's just a step deeper into the building operations. So as we touched on, this actually says fundamentals for energy efficiency operations, but this is the lighting fundamentals that they will cover: energy conservation opportunities, indoor environment, high levels. But I'd like to go deeper into the level 1. And this is really what SPEER focuses on the most in our territory. And level 1 covers, the students will get 7 course books that they get to take home: energy efficiency operations for HVAC, measuring energy performance. So this is a big benchmarking your building, right? You can't measure what you don't know. So we teach these students to go into Energy Star, how to use Energy Star benchmarking and the importance of it. Lighting fundamentals, HVAC control fundamentals. There is a large amount of folks who don't have access or don't even know how to read their commercial buildings utilities and utility bills. So we're really teaching them how to get in and the basics of operating these mechanics and how to read these utility bills once they start improving their buildings. And I will touch on the five projects to follow, and I don't really need to cover level 2. But as again, it's a full scoping building operational improvements. There's a bit more deeper dive into water efficiency, and then there's that peer exchange project that I mentioned earlier. So for fundamentals, it's just one comprehensive test at the end for level 1 and level 2. After each class, students will have an open book 20-question test that they have to pass with the 70% or higher. They can retake that if necessary. They have a learning management system where they can go in, take this test, and then also get additional supplemental information or rewatch trainings on some courses or materials that they might need. And the project assignments. So this is just back on the job. In between classes, these participants will ensure that they are fully understanding what they're learning in the in-class test and put it to their projects. So this can look like conceptually mapping the integration of a building systems and how the concepts will interact with each other and their building, its occupants, the environment. As a BOC project, these participants will create an HVAC equipment floor plan. So they will identify primary heating and cooling and distribution lines. As we know, the main part and cost of energy consumption in a building is their HVAC system. So that's a large driver. I think we touched on heat pumps earlier. There's more coming out about commercial heat pump rooftop units. So as more of these come to market, the books and the curriculum is always being updated to accommodate, the new adoptions in this field. And then this is what the credential structure looks like. So you go through the trainings and you will receive your credentials. So for example, for level 1, it is your training certificate of completion. Students receive this credential once they go through all the courses, complete the 5 projects, and pass all of the tests following each class. The certification exam, while it's not required, it is aligned with ISO 17024, so it is internationally recognized. And in order for students to receive this, they will go to a testing center and have 3 hours to pass a test with 67% or greater. There's also a blueprint on the National BOC website that kind of breaks it down for, what the test covers. So you have 25%, you kind of know what to study on. Okay, let's see. And I think I just touched on this, but to earn your TCOC, the in-facility projects, the test, and the completion. And to dive deeper into the certification exam, not required, but again, encouraged. It's 120 questions. It is at a testing center. It's not open book. It's computer-based and covers the course material as well as the knowledge that was gained on these on the job projects. Maintaining BOC credentials are done at the national level. It's an annual fee of $75, and they will reach out to you and let you know whenever you need to renew your certification. And there's a number of ways that you can maintain maintenance points, which is required each year, and that is through enrolling in BOC web-based technical webinars, attending continuing education opportunities. They encourage you to complete energy consumption benchmarks for the previous 12 years and Energy Star portfolio, which is what these students will also learn. So there's a number of ways that you can maintain this. And let's talk about cost. Everyone is always interested in what these fees will be. So fees range anywhere from $1,600 to $1,800 for in-person versus virtual. These classes used to only be in person. Of course, during COVID, we took it to offer this on demand, but it is still offered in a live setting via Zoom. So the students can interact with the instructors, ask questions, and this also helps with being able to fill courses quicker, but also not having to take the operators out of their building should they need to step out for a second. The fee that I just mentioned covers all of the student handbooks that will be mailed to them, access to learning management system, their credential, the instructors' fees, and the instructors are very good about making themselves available to the students outside of the class should they have any follow-up questions. The BOC.info, I believe, is the national BOC website. Of course, SPEER has a whole page dedicated to BOC as well. This has some more deeper dive into the savings reports, credentials. I would say the savings reports for some nighttime reading, but it does have a lot of really great, valuable information. And I lastly want to touch on funding and resources. Sometimes the cost can be prohibitive for a few folks, and there are currently a few funding opportunities out there. SPEER is working with several universities who are implementing BOC into their college campuses. Several are through EPA's community change grants, and I'm happy to kind of dig deeper into these if anyone wants to follow up. The Community Change Grant is a partnership between two community-based nonprofit organizations. This can be a federally recognized tribe, a local government, or an institute of higher education. This is the notice of funding opportunity is due November 21st of this year for that. The EECBG is a funding program that is for states and local governments and tribes to reduce energy use and reliance on fossil fuels and also improve energy efficiency. This is due October 31st, I believe, for states and local governments, and I want to say May of 2025 for tribes. Grants.gov has a lot of great resources and upcoming funding opportunities. And then one last note I wanted to mention is a lot of times at this time of year, local governments will be kind of wrapping up their funding or getting prepared to allocate funds for next year. It's a great time to either work in training if interested and set funds aside, or if there is a pool of money left over, to dedicate those to some of their facility managers. And I believe that is the last slide.
Perfect. Thank you, Liz. Very interesting presentation. I would now like to introduce our final speaker, Jonathan Kraatz. Jonathan Kraatz is the Executive Director for the U.S. Green Building Council Texas chapter. In 2015, Kraatz was named Interim Executive Director over the formation of USGBC Texas, bringing together green building resources and knowledge from across the state. He facilitated the merger of the 4 legacy U.S. Green Building Council chapters in Texas and accepted the permanent role in January of 2016. Previously, he served as Executive Director for the USGBC North Texas chapter since 2010. And he was hired at the chapter's media and communications strategist and was quickly promoted to more responsible positions within the organization. He earned a Lead Green Associate credential in 2010 and speaks regularly about the chapter's mission, leadership in energy and environmental design, or LEED rating system, and building sustainability. Jonathan, you can go ahead, take control, and begin your presentation.
Great. Thank you so much, Corinne. And Cliff, good to see you again. David and Liz as well. Thank you. Let's see. There we go. Is that changing now?
Yes.
All right. Cool. So really, we've talked a lot about measurement, benchmarking, verification, all of those type of things. One of the tools, I know they mentioned Portfolio Manager a number of times. It's a fantastic tool. Another one I'd like to bring into the conversation is ARC, which is created by USGBC and GBCI, Green Building Certification Inc. Created ARC to kind of be a kind of backbone and a visualization tool for looking at the information that you're collecting. It also is part of the certification process for LEED, but is not only used for that. So really, ARC tracks performance of buildings and other spaces, looking at energy and emissions, water, waste, transportation, as well as a human experience. So it takes the metrics from and the KPIs from Portfolio Manager and expands upon them and actually goes deeper. To do this, we definitely did not do this alone. There are more than 25 active partners who are contributing to its development, looking at groups like Moody's and others, especially when you get to climate risk analysis. There's a lot of outside information that is brought into this. Here's kind of a representation of some of the folks involved with this, and including Portfolio Manager. It plays a key role in this. So what does ARC actually do? There's a score. It scores any project anywhere at no cost. I will emphasize the at no cost portion of this. It gives you a benchmark that compares projects to its peers using performance standards as well as custom created targets for individual owners or managers. And it allows you to communicate and analyze this information in ways that are easy to digest and understand. Who is using ARC? Primarily facility managers, corporate sustainability, property management companies, higher education. And that's not just in Texas, not just in the US, but globally. This system has been used going back, it's about 10 years old now. So by the numbers, we're looking at more than 20,000 active users, more than 100 billion square feet. Actually, that's an old number. It's closer to 15 billion square feet at this point in more than 140 countries. So you see the progress of when this project was launched in 2017, and then you can see a spike there whenever things really came on board in 2021. People were really paying more attention, particularly around air quality and some of those measures during COVID. So I think there's a lot of valuable data that can be extracted from these reports over time. Again, primarily in the United States, and then next would be Canada, and then other folks around the world. This is a global product. Primarily office and retail. as well as education are really into this. How did I get my headset back from my phone? Thank you all for that brief interruption. But really looking at the projects that are using ARC, only about 3 of every 10 projects in ARC are actually a LEED certified building. So more than 60% of the projects are not. They're just using it for tracking purposes and to track improvements over time. And these are things that each individual building owner knows. And that is, again, what you said, you can't improve what you're not tracking. Looking at this to kind of bring information in, this encourage to load all the information that you have about your building, your water data, your energy data, any other data that you have that may not be relevant to every other building, but it is for you. You can put this in and it tracks it and scores your project for free. You can score 1 or more categories at a time. And you can also use ARC as a path for certification if that is something you do want to pursue. Currently, the version of ARC, a version of certification available through ARC is using LEED version 4.1, or also for recertification of facilities that are LEED new construction, and then those that are already certified under LEED for existing buildings as well. This allows you to kind of score to see where your properties are with regard to each of the assets that you have that are in, that would be performing in different categories, looking at where they would fall if they were certified or if they were submitted for certification. There are also ways through ARC to earn recognition without doing through a full LEED certification. You can do certifications for energy, water, waste, transportation, and also the human experience piece, how the people are interacting with the building and how they are, what their experience is around that. It does also allow for LEED certification or recertification, as well as stepping up to a LEED 0 certification, which those are available for energy, water, waste, and carbon. ARC also supports other reporting processes too, looking at GRESB, the Global Real Estate Sustainability Benchmark. For building operations certifications, it incorporates that, energy ratings, risk assessment, waste management, employee health and wellness, tenant satisfaction, tenant engagement, as well as portfolio targets. And I'll look at the portfolio piece again here in a moment for those owners with more than one building. Again, benchmarking and building performance standards are key to us transforming what our building market is and reaching the carbon and emission targets that we have set individually and as larger entities as well. ARC does also allow you to put in custom targets, like if you have set your own corporate or city level targets for different performance metrics, you can put those in and measure against where you have set those targets. Are you actually reaching those goals? I'll also add for any of these services within this, I know that my contact information will be on the website for this, as well as in the notes that Corinne will share later. We can set up free demos and other question sessions on this for you if you are interested. So energy efficiency analysis since 1993 looks at global scores, looking at how things have changed and how the markets have affected things and what the differences in energy efficiency has been for that. But it also allows you to analyze your portfolio and your buildings to understand what the efficiency is over time based on different weather conditions, as well as different fuel mixes and that sort of thing that you have available now. basically tracking your performance as well as analyzing your efficiency within that. And you can also put in variables within this to show if we made certain changes, what the projected outcomes would be. These are projected outcomes, but it does also allow you to look at where you are performance-wise, what your scores would be, looking with a lead framework, as well as to communicate what the efficiency would be where you are, as well as what it would be with certain changes that you have modeled within this. Again, allowing to track up to 10 projects at a time and show where they're performing relative to one another, as well as themselves over time. Green building and EU taxonomy. This does also help crossover for anyone who is doing international reporting, and particularly with European crossovers. It does help with the matching the apples to apples and oranges to oranges within this. It helps you make sure you have all of the pieces aligned and collected properly for that. This allows you to go by project type, input your information, look at what your objectives are, and then look at what the safeguards are and those pieces within the protocols that you are establishing for your projects. ARC does also allow you to download your scores, download the reports, does also look at climate risk. These are pieces that are actually done. The climate risk analysis is actually done through Moody's and allows you to look at different levels or different threats and how your project is being safeguarded in relation to those. With resilience primarily is one of the things that, as a number of the speakers before have talked about, resilience isn't only energy reliability. Resilience is also related to heat, flooding, other weather issues. Our folks down in Houston have had a few issues in the past few months with flooding, hurricane, and otherwise that are definitely pieces that are risk factors for folks here in Texas particularly. Again, I mentioned the portfolio tools. This allows you to track not just one building, but all of your buildings individually and as a whole, to be able to see where you are based on, I took that one out. Basically looking at each individual project, each individual facility, to see where it scores and how it's doing for energy, water, waste, transportation, and the human experience for that. Again, those are the same slides from before. Again, okay, I left something here that I thought I took out. So basically, if you want to get started with this, let me know. It is like I said before, as Cliff mentioned, with Portfolio Manager, it is a free account and allows you to kind of load all your information in, see where you score, see where it scores against a facility, scores against its peers, or as your portfolio scores against itself. And then if you want to pursue further certification with LEED or Energy Star or others, it will give you the operation for that. I know that David was mentioning the code cycle. LEED also is on an update cycle where you've got a 3 and a 4-year cycle for IECC and ASHRAE 90.1. LEED version 5 is moving into a 5-year cycle. So looking at for a background on where LEED is, it is market-based rating system, but it is shifting a bit this time and looking more towards near zero carbon, as well as adding an equity resilience, and promotes wise use and safe utilization of all resources. So the next version will actually focus a bit more on specifically on decarbonization, ecosystem conservation, as well as the human impact and human experience that we're showing. As I mentioned, timelines, they're originally started in 2023 on the development of LEED version 5. In 2024, the beta versions of the operations and maintenance system was released. Again, looking at existing buildings and their importance, the existing building system was the first to be released and the first to be developed, with the new construction to follow afterwards. There's been currently one public comment period. As a hint, there will probably be more than at least one more coming up that will be announced shortly, I hope. And then looking at how things are refined based on those comments and market and other reactions to that, we'll go for a ballot for certification with projected implementation in 2025. This is a 5-year cycle, which theoretically LEED version 6 would then be launching in 2030. As I mentioned, the impact areas, ecological conservation and restoration, quality of life, and decarbonization. It's a major shuffle of how the LEED rating system has been arranged and utilized over the past 25 years. So this is a significant shift for this update. Decarbonization, we've talked a lot about that already. Looking at operational carbon, embodied carbon, as well as transportation being calculated in that. Quality of life, these buildings we're doing have impacts on people. Looking at those crucial aspects of sustainable building that include human health and well-being, resilience, equity and inclusion, as well as how buildings and projects affect the community as a whole. Ecological conservation and restoration emphasizes strategies and actions that can be implemented at the individual level to limit the impact we're having on our environment, or to actually rehabilitate or restore ecosystems where possible. This is a flexible system that does give options. There is not a singular prescription anywhere. There are no two projects are the same, as everyone knows. So there are different changes in that. There are also some point thresholds that have been raised. There are also references other standards also for being above code. The base standards do shift as those codes are updated. Again, the operation and maintenance portion of LEED is positioned every building on a path to improve performance while maintaining the pursuit of market transformation and leadership. What we're doing in this, providing education and leadership, establishing that roadmap for actionable transformation criteria, looking for buildings to achieve certification through measurable building performance, as well as rewarding buildings that start down the path toward decarbonization by creating strategic long-term plans and implementing immediate steps within that. This is kind of the reshuffle of where the credits have been in the old system of integrated process, location and transportation, sustainable sites, water efficiency, energy efficiency, materials and resources, indoor environment quality, and project priorities and innovation is shifting. Those same credits are here, but they're moved over into decarbonization, quality of life, and ecological conservation and restoration. If you'd like more information, you can visit usgbc.org or the QR code on the screen. And I went through pretty quickly, and I will now turn things back over to Corinne.
Great. Thank you, Jonathan. So we do now have some time for questions. So you can ask a question one of two ways. You can either raise your hand, and I will call on you to unmute and ask your question, or you can put questions in the chat. and we can answer questions that way. Yes, Jonathan.
So one question I had, this is actually going for David. I know you mentioned, and Cliff had mentioned scope 1, scope 2, and scope 3 emissions. Can you give us a explanation of what that actually means?
Yeah. So in very, very generic terms, so I tell my clients, I said, scope 1 is what you measure at your building. And so anything that you can manage that is a utility coming across your building boundary that's metered, that's in general terms, that's a scope 1. Scope 2 is anything from your meter to your supplier where they're doing production of utilities. And that includes transmission costs and the like. Scope 3 covers a bigger umbrella. It's if you look at it from a standpoint of like a retailer, it's everything in your supply chain, but it also can include your employees' carbon footprint, traveling back and forth to their home, anything that would anything you purchased and you're reselling, the manufacturer, the carbon footprint of that product, so it's, I say scope 3 is everything else. So it's easy to meter and manage and control as an owner operator. Scope 1, you have to work with your utility provider, or you have renewables offsite that you're managing to do scope 2. And then scope 3 is one of those big umbrellas that's really, really more difficult, more challenging to manage. I don't know, Cliff would add to that.
Hey, so those that know me, my response is going to be the Pareto rule. Do the 80% benefit, which is go stick a PV system on your building and find a creative way to pay for it with all the incentives, and that'll make a big dent in your scope 1.
Great. Thank you, Cliff and David. Does anyone else have any questions? I do have a question, kind of generally, something that we've been hearing a lot about are energy management systems, and how they can help monitor and manage energy usage. My understanding of these is that it's something that's measuring in real time. So I'm just wondering kind of if any of you have experience with that, how these can maybe be utilized with other benchmarking tools, kind of the benefits or the cons, I guess, of using these over other benchmarking options.
I'm going to let David and Cliff, I'm going to say one thing before I let Cliff get into the details of this. It's usually not an either or, it's a energy management and scenario. So it is a great tool to put into your portfolio for energy management and benchmarking. Now I'll let Cliff get into the details of how they work, because I know he's much more versed than I am there.
Yeah, well, I'm not going to add a whole bunch to it because I've slept a few times since I've been in the controls business, but we work on projects right now that are controls. And as you know, let's say, well, Corinne, your question was something about the value of, BA building automation and DDC control and such. And you remember the little slide there, if you can't measure it, then, you're not going to be able to control it. So it is outrageous if you want to, I mean, I don't know how strong of a word we can find that people who are responsible for, a large use of the energy and, the associated emissions are not measuring, the sources, the things that are causing that. So real often people think of control system as being sequence of operation. It gets hot in the building, so the temperature needs to be adjusted. That's control. But what needs to be attached to that is what is the kilowatt demand and the kWh, and quite honestly, the carbon impacts, for that device. And so all of that can be tracked simultaneously. I mean, if we're really going to make a dent in trying to get to net zero. So building automation and control systems are imperative on that. And I'm anxious to see what does the control industry do with AI, integrating AI into all of those on-off switches and analytic, resets and such that are embedded inside of a building automation system. So again, how are you going to get to 100% of the benefit out of what a control system will do? Cliff's thing is don't go for 100%, get 80%. And that means, just do 20%. So take 20% of your air handlers and your lighting and your building and do a deep dive on the control, get that perfected, and you're going to get 80% of where you want to go. If there's a control person that's on this webinar that would like to chime in and tell us about AI, I mean, it would be interesting to hear the latest and greatest from that industry.
I can jump in a little bit there, and I got to be careful because it's very, very early in the, I call it just advanced machine learning because AI gets utilized as a marketing term when you got really just a higher order machine learning. Let me first say that absolutely, when Cliff said you can't measure you can't manage what you don't measure. If I ever get a tattoo, that's what going to be tattooed across my chest right there, because that's really one of my stump speeches. You got to have advanced metering, but not just metering. You got to have sensors to be able to pull data. So we live in a world now where, in general terms, sensors, metering, and data management is really, really inexpensive. And so there's really no excuse for people to really have what I would call DDC rich or technology rich buildings. And the code really has evolved to really mandate that, even to the level where it's mandated on the current 90.1 and IECC that you need to sub-meter systems like your lighting systems, your HVAC system. So because it's really, really cost effective and inexpensive. Well, where AI is going to come in, we need all that data, all that measurement controls to not only tell you real time what's happening, the real emergence is going to come into modeling, where you'll be building digital twins and using tools such as model predictive control, white box models, gray box models, that's actually going to predict what your energy is not only for tomorrow and next week, but even be able to respond real time to occupancy patterns where we're not doing a good job of measuring occupancy. We're using the proxy of CO2 for ventilation, but that can be woefully wrong and can be inadequate as well. But we have machine vision, you have other technologies that can tell down to the person how many people are in a building. And so you really, the next frontier of energy optimization is going to be at the person level. And there's been a lot of work and development with, look up the Edge building in Europe. That's Deloitte's headquarters there. That came out in the early, about 2012, 2013, I think. And so those type of things are going to emerge with the advanced HVAC controls that's driven by advanced machine learning, and they can do the math and predictive. Now, the challenge with that, it requires a higher level of technician to really set it up and maintain it. So that's where the gap is as much as anything with the technology advancements. Let me one more thing. Recall my slide that most buildings in the CBEX database that is in our inventory was built before 2010. Most of those have very low level type of DDC type controls. So they're all ripe for upgrades.
Absolutely.
Great, thank you. Anyone else have any other questions? No.
Connie, is one of those requirements, one of the advances for the training? Excuse me, I should be asking this to Liz about the training. I didn't see in the slide that every kilowatt hour that a certified operator saves generates money savings for the owner, and the guy who has the certificate, he gets to keep about half of that savings. Isn't that correct?
That is correct. Thank you for pointing that out. I can't believe I forgot to include that. Very key piece.
Okay, so if there aren't any more questions, we're going to go ahead and start wrapping up, but I do want to highlight a few resources before then. So first of all, NCTCOG is going to be hosting its quarterly meeting of the Regional Integration of Sustainability Efforts or RISE Coalition on July 31st. And this is a really great opportunity to connect with local governments and other groups to focus on sustainable practices within the region. So if you are interested in that, you can visit the committee page there linked on your screen. We have many ways that you can stay informed about upcoming events and workshops like this one. So please visit our web pages, and you can also join our email list to stay up to date on relevant topics. We also have a few sites related to energy management. So our Conserve North Texas website houses resources on fuel, energy, and water topics, and it contains past workshops, podcasts, reports, and more to support responsible resource conservation practices. That's also where this webinar recording and slides will be posted. Go Solar Texas houses a multitude of resources for Texans interested in learning more about going solar, as well as Texas-specific resources on best management practices for local governments. And then finally, our energy management efficiency and renewable energy webpage has information about our regional energy management program. Also like to highlight PACE, which stands for Property Assessed Clean Energy, as a resource for lowering operating costs and making energy efficient upgrades to properties. So NCTCOG has developed a story map that was developed earlier this year, and it showcases PACE adoption and PACE funded projects in the region, as well as provides information on how PACE can be used in your community. And then finally, I just want to review some of the resources that are available through CECO. So CECO offers technical assistance, including PEAs, which I'll discuss shortly, and energy management policy development. CECO also provides support for state-mandated local government energy reporting. And additionally, Watt Watchers of Texas is a program that CECO provides for use in schools and at home, and is designed to promote behavior change for better energy management. So PEAs are provided at no cost to help support energy management policy development and provide facility benchmarking. This information can then be used to create energy efficient guidelines. CECO contracts with engineering firms to provide technical assistance on energy or water related matters, and the link to sign up for the technical assistance is there at the bottom of the slide. And then finally, the Lone Star program is having open enrollment until August 30th, 2024. I do want to point out that CECO has currently paused the receipt of applications, but those will reopen on August 1st. This is a revolving loan fund that provides low interest rate loans to assist Texas public institutions to finance their energy related cost reduction retrofit projects. So just some closing reminders. Again, these slides and the recording, as well as those full speaker bios, are going to be posted on the Conserve North Texas website shortly after this webinar. If you can, please fill out the webinar evaluation linked on your screen. We'll also be dropping that in the chat. And what these evaluations do is they help us to improve future workshops and webinars, as well as link you up with CECO to receive more information about their resources. We'd also like to invite you to complete the in-kind match form on linked on your screen and in the chat. So participants in today's webinar whose time is not paid for through federal dollars may donate the value of their time to NCTCOG through an in-kind match, and further details are in the form provided. So I just want to close out today by sharing our partners' contact information. Adam Mueller, Program Specialist with CECO, and Sean Auckland, Program Manager with SPEER, are both available to provide support and assist with any questions that you may have. And their emails are there on your screen. And then here's some contact information for the COG team that works on the energy management project. So I just want to say thank you again to everyone who joined us today. And thank you to our speakers, Cliff, David, Liz, and Jonathan, for taking the time to share their knowledge with us. This webinar is now over. Have a great day, everyone. Thank you.